domains, ranges, and intercepts of functions. So our objective here, we want to identify the domain, the range, and the intercepts of a function from its graph. Okay, so what do we know? We know what a function is. A function is a relation in which each component of the domain is the set of all x values or input values, corresponds to exactly one component of the range, which is the set of all y values or output values. A function relates an input or an x value to an output or a y value by a rule. We also know what an intercept is. An intercept is where the graph crosses or touches an axis. An x-intercept is where the graph crosses or touches the x-axis. A y-intercept is where the graph crosses or touches the y-axis. Before we get into doing our objective, let's define interval and talk about and discuss the ways we write an interval. An interval is all the numbers between two given numbers. Okay, how do we express intervals? Well, we express intervals in three popular ways. There are some other ways. I'm going to do the three what are probably the three most popular. One way is to express them as an inequality. So this says x less than or equal to 20. That's an interval, which means all the numbers that are less than or equal to 20. So let's jot that down. All numbers less than or equal to 20. So the first way we express an interval is we use an inequality. The second way we express an interval is to use a number line, okay? So this number line is we're showing the numbers between 0 and 20. So all the numbers between 0 and 20. However, note the open circle here. I'll put open circle with an arrow there. And note the closed circle over here on 20. Okay, the open circle means do not include. So 0 is not in our interval. We're not going to include 0. We're going to include 0.00001, which is barely to the right of 0. We're not going to include 0. A closed circle means include. So 20 is included in our interval. So how we express this in writing? All numbers between 0 and 20, not including 0, but including 20. Okay? So this is the second way. We've dealt with intervals. Let me come up a little bit here. We've shown how you express an interval using an inequality and using a number line. Okay, let me get my paper to my next sheet. Give me just a second here. Okay, the third way we express an interval is using interval notation. And we're going to make a lot of use of this, okay? Interval notation. All right, so here we have this interval says between 5 and 12. The smaller number is always to the left. The larger number is always to the right, as if we're on a number line. Okay, so 5 and 12. And the parenthesis, so we have a couple of different symbols here. We have a parenthesis on the 5. we have a bracket on the 12. So on the 5, we have a parenthesis, parenthesis, and on the 12, we have a bracket. The parenthesis means do not include. It's kind of like an open circle. Same meaning. Means do not include. A bracket next to a number means include. Again, kind of like a closed circle. Okay, so here we say, how do we read this? This is the interval between 5 and 12. So all numbers between 5 and 12, whoops, that's a 12, not including 5, including 12. So there's our interval. Anything between 5 and 12, not including 5, but including 12. So it can be 12, it can be 12, it cannot be 5. It can also be 5.5, 6, 7, 8.279, etc., anything in between there. I've given you a chart here, all three methods together, and you can see between 1 and 2, including, not including, with the inequality symbol, with the number line and interval notation, and also one down here that gives you the inequality, the number line, and the notation for include but do not include, like I have showed you in other examples. So a nice chart here to help you make sense of all that stuff. Now, let's take a look at how this comes into play when we talk about the graph of a function and defining its domain and its range. Give me a minute to get my act together. I think I'm good. Okay, so we look at the graph of a function. Its domain is determined by the x values that are on the graph. Its range is determined by the y values that are on the graph. Okay, so we'll do 4 examples here. Identify the domain and range in interval notation. That was our last example, using parentheses and brackets, and the intercepts for each function's graph. So here's our function. Okay, let's first do our domain. And our domain, as we know, is our x values. Okay? Well, our domain, I'm going to write on the x-axis. Our domain goes from here to here. So our x values go from -2 to 1 on our graph. -2 to 1. Okay, so I'm going to put down -2 up to 1, from left to right, from smallest to largest. Do I include -2? Well, that's a closed circle. So I include -2 with a bracket next to the -2. Do I include +1? Well, that's a closed circle, so +1 is included. So our interval for our domain is all numbers between -2 and +1, including -2 and including +1. Now let's look at our range. Our range is the set of all of our y values that are on the graph. Well, it might help you to turn it. Helps me to turn it. Okay, we can look at it like it's like it's the x-axis. So here's the range. The range goes from here to here on the y-axis, from 1 to 3. Okay, the graph goes, from 0 to 3 on the y-axis. Okay, so come back to here and get my paper hopefully straightened out for you. Our range goes from a minimum of 0 to a maximum of 3. As I look from bottom to top, 0 to 3. Is 0 included? Well, there's a closed circle on 0, so 0 is included in the interval. Is 3 included? Well, there's a closed circle where y is 3, so 3 is included. I'll enclose that with a bracket. Okay, so any value between 0 and 3 inclusive is on the graph as part of our range, part of our output values. Okay, now let's do the x-intercepts. X-intercept or x-intercepts. I'll put a parentheses around an S. Where does this graph cross or touch the x-axis? It only crosses or touches the x-axis at -2. So we have an x-intercept at -2. Now let's do our y-intercept. Where does this graph cross or touch the y-axis? It touches here, it crosses, at 1. So our y-intercept is at 1. Okay, so another example here. Here's another graph of a function. Okay, let's first do our domain. Remember, our domain is the set of x values that are on the graph. Okay, x values, I'm going to mark them on the x-axis. It goes from here to here. Okay, right there. That's what our x values do, right there to there. These are my x values. -3 to 2. Okay, from least to greatest. Okay, do I include -3? Well, that's an open circle, so -3 is not part of the domain. So I'll put an open parenthesis next to the -3 to show that -3 is not part of the domain. Is 2 included in the domain? Well, when x is 2, I have a closed circle, so 2 is included, and so I will enclose 2 with a bracket. So x values are all the x's between -3 and 2, not including -3, including 2. Let's look at the range. The range is the set of all y values that are on the graph. And again, I recommend, if it may help you, turn the paper. Okay, let's take a look at it horizontally, which seems to help a lot of us. Okay, this graph horizontally goes from 1 to 2. It doesn't go very far. Okay, it only goes from here to here in the graph, from 1 to 2 on the y-axis. Okay, so let me get my paper again set up. Our range goes from least to greatest, 1 to 2. Well, is 1 included? Well, if I look at one y value, I notice I have an open circle, so the y value of 1 is not included. If I look at 2 on the y-axis, it corresponds to a closed circle, so I put a closed bracket. My range for this function goes from 1 to 2, doesn't include 1, but does include 2. Okay, x-intercept or intercepts. Does this graph cross or touch the x-axis? And the answer is no. It does not cross or touch the x-axis. So I have no x-intercepts. How about a y-intercept? Does this graph cross or touch the y-axis? Yes, it does. It looks like it's at approximately, let's call it 1.6. I don't know exactly. I'll put a little wavy equal signs and put about 1.6, give or take. Not too concerned about being precise, just noting that it has a y-intercept right around 1.6, 1.5. Okay, let's do 2 more examples. Okay, again, give me half a second to get my act together. All right, let's see here. I think I'm good. Let me get my other paper turned over. Okay, letter C here. I've got a U shape, so let's take a look at my domain. And again, my domain is the set of all x values that are on the graph. It looks like my x values go from -2 to 1. My x values are between these two. I'll write them down in order from least to greatest. Now, is -2 included? Well, it has a closed circle, so I'll close it with a bracket. Is 1 included? It has an open circle, so I'll enclose that with a parenthesis. So my domain is all the x values between -2 and 1. I include -2. I don't include 1. How about the range? Again, the range is my set of y values. Okay, let's turn it and take a look. Okay, well, my range on my y-axis, it goes from 1 right here all the way to 5. I realize I got some repeating here. I don't care about that. My range goes from 1 to 5 on the y-axis. Okay, I'll come back. I think that turning paper thing is kind of a nice way to see it clearly because we're really used to seeing things horizontally. The vertical is a little tougher. So the range goes from 1 to 5. Is 1 included? Well, the 1 is here. It's included. There's no open circle there. So the 1 is included. Is 5 included? Well, the 5 corresponds to here. That's a closed circle. So the 5 is included. This range goes from 1 to 5 on the y-axis, including 1 and 5. Okay, do I have any x-intercepts? Anywhere the graph touches the x-axis? And the answer is no. I have no x-intercepts. Do I have a y-intercept? And the answer is I do. The graph crosses the y-axis at +1. So there are my intercepts. Okay, one more example, domain and range and intercepts. This function goes from here and it goes all the way, this arrow is showing me. Let's highlight this arrow. This arrow is showing me that this thing goes on forever to the left. So it's getting further and further left, and it's getting higher and higher. Okay, so domain. Again, my x values. Well, I know it stops here. I can see that, but it goes on forever this way. So my domain is going to go from -infinity to +4. The arrow says it just keeps on going, and that in this direction is -infinity. Well, -infinity is always enclosed with a parenthesis because it's not a number, it's a moving number, it's an idea. So you always enclose -infinity and infinity with a parenthesis. The 4 as a closed circle, which I kind of drew over, so I'll put a bracket on the 4. So my domain, all x's are on this graph, everywhere from -infinity way over here to the left, all the way up to +4 and including +4. How about the range? The set of y values. Well, again, let's turn it. Okay, my range on the y-axis starts here at 0. And then it just keeps going. It just keeps going this way. This arrow says it's not getting higher very fast, but it's gonna go to +infinity. So from 0 all the way to +infinity is my range. Turn it back. And we'll say the range goes from 0 to +infinity. Now, of course, infinity is always enclosed with a parenthesis because it's not a number, it's an idea. Is 0 included? Well, 0 on the y-axis has a closed circle, so we're going to put up a square bracket next to the 0, and that's my interval notation. Do I have any x-intercept or x-intercepts? And the answer is yes. This graph touches the x-axis at 4. So I have one x-intercept. Do I have a y-intercept? And the answer is yes. The graph crosses the y-axis at 2. So I have a y-intercept at 2. So there you have it. Interval notation, domain, range, and intercepts.